What you see here is looking from the top down. So this is the top of somebody's head, bless you. This is the nose, ears. Okay. Starting here, you have the opening in your ear. Does anybody remember what that's called? We used it as a landmark when we did goniometry. Yeah, good. So that's your external auditory meatus. Perfect. So we're going to start. Okay. Try and draw it on both sides. Okay. After your external auditory meatus, you have the next part of your ear coming in. This is your ear canal. And what cranial nerve was it that was responsible for ear canal general sensation? Does anybody remember? 7. Okay. Cranial nerve 5, outer ear. Cranial nerve 7, ear canal. And coming off the ear canal, the next piece that you have is called your middle ear. What cranial nerve was that? 9. Very good. It's your middle ear. Okay, nothing too tricky yet, right? Now the next part is actually housed in bone. It's part of your vestibular system, and to make it easy to follow, what I like to do is represent it as a box. So think about a 3-dimensional box. Okay? Coming off the middle ear, and this part's a bony. It's part of your bony labyrinth. So I'm going to make a box here. Okay, and that box is going to have 3 dimensions. So if I put in the other parts here, there's one box. So here's the top of the box, there's the side of the box, and there's the back of the box. Okay, and I'm going to draw a box on both sides. This box is made of bone. In reality, this structure doesn't look like a box, but I think if I draw it as a box, it's easier to see how other parts connect to it. And it has a name. Like I said, it's made out of bone, and it is called the vestibule. Vestibule. That's your vestibule. Vestibule is part of the vestibular system, made of bone. Okay, so off of the front part of the box, so the part that's kind of closest to your eyes coming off here, there's something that's the sensory organ for hearing. That's going to be your cochlea. So when I draw the cochlea, if I just draw it, it comes off the front of the vestibule, and it's kind of little snail shell kind of thing on the top. That's your cochlea, and this is the sensory organ for hearing. Come here. Okay. This is the cochlea, and that's the sensory organ for hearing we're going to talk about later in the talk. Focus on the vestibular system, but the cochlea is housed in bone. It's part of the bony structure, and it's connected to the front of the vestibule. right, thinking about the vestibular system. The vestibular system has the vestibule. It also has three things that are called semicircular canals. Okay? It's going to be the job of the organs inside the vestibule to detect linear forward and backward motion, up and down motion. It's going to be the job of the semicircular canals to detect when your head's turning. If you remember the video, they talked about head turning being a problem. That's the part, that's the semicircular canal part. Now, there's three different kinds of semicircular canals. One comes off the side of the box. Okay, so it comes off the side of the box here, and then it's a little circle, and it connects to the back of the box. Okay, and there's one of these on both sides. So semicircular canal comes off the side of the box and connects to the back of the box. Okay, this is one of the semicircular canals, and this is the, you can think about it, the position of it is kind of horizontal, and it's coming off the lateral, or the outside of the box. So it's known as your horizontal or lateral. You'll hear both words, and it's one of the semicircular canals. In particular, since your horizontal canal is coming off laterally, it's involved in detecting the no motion. You're shaking your head no. Okay, you see that? So it comes off the side of the box, connects to the back of the box. And then there's another one, let's make it, okay, there's another canal, okay, there are three of them. There's one canal that comes off the top of the box. Okay, this is going to be known as your superior or anterior canal. You'll hear both terms. Okay, it comes off the top of the box and just comes back to here. Okay, so coming off the top of the box, it itself isn't going to connect to anything yet. And this one is going to be your superior or anterior semicircular canal. We also have one more to think about. And the last one is going to come off the back of the box. Okay, it's going to come off the back of the box and actually connect up with the superior or anterior semicircular canal and then come back into the back of the box. Okay, so it comes off the back of the box. That's your posterior semicircular canal, because it comes off the back of the box.
So it's going back to the same side it came from?
Yeah, pretty much, and you'll see that in more detail here in a minute. But yeah, it comes off the back of the box and kind of connects back into the back of the box. And this is your posterior. Comes off the back of the box. It's your posterior semicircular canal. Okay, so that's it in a nutshell. That's the overview. Okay, you need to be aware that there's the vestibular apparatus and the cochlea are both the right and the left sides. You have two. There are two horizontal semicircular canals, two posterior semicircular canals, two anterior or superior semicircular canals, and they all work in conjunction. So horizontal canal or lateral canal works with the other lateral canal. The the anterior semicircular canal of the right ear works with the posterior semicircular canal of the left ear, and vice versa. So they work in pairs. And it's the job of your vestibular system to convey position of the head in three-dimensional space back to your brain. And your brain relies on signals coming from both ears to make sense of where you are. Okay. Questions? Pretty easy? Okay, this is the great big overview. This is the above ground view. Now what we're going to do is we're going to, I'm just going to stick with one side, okay? We're going to look at this right side here. All I'm going to do is I'm going to take this with the next image and I'm going to blow it up and we're going to look at what's inside. Okay, and that's going to be your inner ear structures.
Dr. Barlow,
Yes?
you said that the cochlea and the vestibule are bony.
The whole thing's bony.
The whole thing's
The outside, the whole outside is called your bony labyrinth. We're going to talk about that in a minute.
What are the canals?
Bony.
Bony.
All bony, yeah, that's all your, so there's a bony labyrinth and a membranous labyrinth. We're going to see that here in a minute. Any other questions? Okay, so it's really important. So you have your brain is super important, right? And it's encased in this bone of your skull. Well, this stuff is so important that it's actually encased in bone inside your skull. Okay, we don't want anything bad to happen to your vestibular system. Like I said, this is, see that? So this, all I've done is taken, question? No? Okay. All I've done is taken this here and blown it up. Okay, so we're looking at this right here. Okay. And we go through and start to label some parts here. This is the box that I've talked about previously. So what's the name of this box again? That's your vestibule. Good. Okay, and coming off the front of the box, this guy over here is cochlea. Okay, sensory organ for hearing is inside your cochlea. Okay, thinking this is the front of the box now. Coming off the side of the box here, I have one of the semicircular canals. What was the name of the semicircular canal that came off the side of the box? Anybody remember? Yeah, this is your horizontal or lateral canal. Okay, then you have another one of those canals that's coming off the top of the box, kind of connecting back here. What's the name of the canal that comes off the top of the box? Yeah, let's call it the anterior or superior canal. Again, these are semicircular canals. Okay, the last one coming off the back of the box and then connecting with the anterior canal to come back into the back of the box is your posterior canal. Good. And again, we're just looking at the right, just one of them right now. Everybody got it? See where we are? Okay, and as I've said, this entire structure, this is known as your bony labyrinth. Okay, so the bony labyrinth is composed of the cochlea and the vestibule and the three semicircular canals. The cochlea is attached to your bony labyrinth. Okay. Each of the semicircular canals has a big bulge in the area where it connects to the vestibule. Okay, this bulge, each of these bulges have a special name. They're called ampulla. A-M-P-U-L-L-A. That's your ampulla. Again, the outer structure is all made out of bone. Now, inside the bone, there's a membranous structure. Let me write that down. So this is all this bony structure, the entire thing on the outside is called your bony labyrinth. There's your bony labyrinth is the whole thing. Anything on the outside. On the inside, you have a membrane that lines the bone, okay? And this membrane is contiguous with the cochlea here, like that. It's going to have a little bit of a narrowing and then come out to be part of another structure. I'll label that here in a minute. And then it's the membrane itself lines every semicircular canal. So it's going to go through. This is just all membrane that's lining the semicircular canals and the vestibule. It's all one contiguous membrane. You're going to see how it connects here in a minute. But the ampulla is the part of the semicircular canal that connects to the vestibule. And then you have a couple of other structures to be aware of here. But essentially, everything is connected. It's one contiguous piece. So this membrane that lines all parts of the semicircular canal and vestibule, it's all connected together. It's called your membranous labyrinth. That's your membranous labyrinth. And your membranous labyrinth is filled with a fluid. Okay. The fluid inside the membranous labyrinth is known as endolymph. ENDOLYMPH. And that's just the fluid that's inside your membranous labyrinth. You have bone on the outside, and then membrane, think like garden hose, and then inside the hose or the membrane is a contiguous solution of fluid. That fluid is known as endolymph. Okay. As I said previously, the three different semicircular canals, horizontal, posterior, and anterior, are involved in detecting linear motion of heads either up and down or left and right. And the vestibule has a couple of organs itself. I'm going to draw them in here, kind of make them in dots. We're going to look at them a little bit more closely here in a little bit, but there's one up front, and then there's one behind. Okay, and this is nothing more than organs that are inside the membranous labyrinth. These organs have names. The one that's closest to the cochlea is called the saccule. S-A-C-C-U-L-E. And the one that's furthest away from the cochlea is known as your utricle. U-T-R-I-C-L-E. Okay, your saccule's closest to the cochlea, utricle's further away. The way that I remember that is they're in alphabetical order. I go from C, cochlea, to saccule, next to utricle. Okay? It's going to be the job of the saccule to detect up and down motion, or when your body's going up and down. It's going to be the job of the utricle to detect linear motion. We're going to look at that a little bit more closely in the next slide, but that's what's coming. Questions? Utricle, U-T-R-I-C-L-E. We're going to look at that. We're going to zoom in even further now. Okay, so overall, coming down, you have this happening bilaterally. We looked at the overview already. Then when we zoomed in, you have your bony labyrinth, which is all present on the outside. You have your vestibule, which is the box, and then your 3 semicircular canals coming off different positions of the box. Inside the bony labyrinth, you also have a membranous labyrinth here, which is just a membrane that lines the surface of the bone. Inside the membrane is endolymph. That's just fluid. It's continually moving fluid, and that's how your vestibular system is going to detect motion. Okay. Inside the membranous labyrinth, there's 2 different structures. The one closest to the cochlea is your saccule. The one furthest away is your utricle. Okay, we're gonna, right now, any questions about that? Kind of starting out broad, and now what I want to do is I want to zoom in to this region right here. So I'm just going to take this whole region and blow it up with the next picture. And that's going to be looking at the saccule and utricle sensory organs. Okay. Looking at the saccule and utricle sensory organs, again, here's my box, right? So this box is called, what was that name again? Vestibule. Good. That's my vestibule. Okay. So to kind of orient you, in this region, this goes to the cochlea. So that's going to be the interior of the front portion of the box. Okay, and then these openings are to semicircular canals. I can put that in there too. Not specifically. And then this is also going to a semicircular canal. Everybody see where we are? Okay, so these 2 different organs that are inside, they're made from the membranous labyrinth. Okay, the way that I've tried to draw them here is to give them some dimension, or a little bit of 3-dimension. And the best way to explain it to you is what I tried to draw here is something like 6 foot above ground swimming pools or whatever. If you can imagine an above ground swimming pool. So here's the bottom of the pool, and then here are the sides, okay, sticking up for both of these. So everybody see where I am? So you've got the bottom of the pool and then on the sides, so sticking up like that and like that for both the saccule. Let's go ahead and label it. So the one that's closest to the cochlea, which one is this one again? Yep, that's your saccule. And then that means this back one here is your utricle. Okay, so inside the saccule and utricle are sensory organs. And we're going to start with the utricle. Okay, inside the utricle, you have a sensory organ here that's on the floor of the swimming pool, if you will. Okay, so I'm just drawing a structure like that on the floor. It's located on the floor of the swimming pool, and it's composed of tall cells. I'm trying to make it 3-dimensional here. So these are tall cells, and coming out the bottom of each of these cells are axons. So each of these tall cells has an axon exiting from the bottom that combined will help to make up the vestibular or part of the vestibular portion of the eighth cranial nerve. Okay, they're nothing more than axons coming out of those tall cells. That's the vestibular portion of cranial nerve 8. Remember, cranial nerve 8 is vestibulocochlear. So there's a vestibular portion, and that comes from the vestibular apparatus. And there's also the cochlear portion, which comes from the cochlea. We'll get to that at the end of the talk. Everyone see where I am? Questions? Okay, so these tall cells actually have cilia. Does everybody know what cilia are? The hairs? Yeah. So coming out the top of of these tall cells, they have cilia sticking out the top. Okay. And just look at these cells. Each of the cell has cilia sticking out of the top. Label that as cilia. Okay, and since each of these tall cells has cilia, they're called hair cells.
Say the name again.
Hair cells? Hair, H-A-I-R. Yeah, cilia, hair, that's where they come from. They're called hair cells because they have cilia sticking out of them. Okay, they're just tall columnar cells. Axons coming out the bottom. Vestibular portion of the eighth cranial nerve. Okay, cilia sticking out the top. And over top, so the cilia are actually embedded in a gelatinous matrix. So if I had to kind of give you a little bit of a three-dimensional feel, or I'll try to. Okay. There's actually a gelatinous matrix over top of these cells. It's nothing more than Jell-O. Label that in red. Okay, this is just gelatinous matrix. Okay, so you have your hair cells on the bottom. Cilia are sticking into a big vat of Jell-O. And then there's also something special that gives the whole system some weight to it. And these are called otoconia. Okay, and they're nothing more than calcium carbonate crystals. Calcium carbonate crystals are embedded, sometimes they can come out, in the top of the gelatinous matrix. Okay, so these black things are called otoconia. Okay, the otoconia are nothing more than calcium carbonate crystals, and they're embedded in the top of the gelatinous matrix. So you can imagine, well, talk about that.
What did you say that they were?
Otoconia. They're calcium carbonate crystals. Questions about that? So you see you have the system of tall hair cells with cilia sticking out. Cilia are embedded in gelatinous matrix, and on top of the Jell-O, there's rocks, essentially. Calcium carbonate crystals that give the whole system some weight. Okay, and this is on the bottom of the utricle. So if you want to think about the utricle being a swimming pool, it's on the bottom of the pool. So telling you that information, is the utricle responsible for detecting motion that's going forward and back or going up and down? And why? What do you think? I see Silas doing this thing here. He's saying forward and back. What do you guys think? Why? What happens? You want to tell me what happens? How do you know it's going forward? It detects forward and back motion. I said it already? How's that?
Yeah, you did one day earlier.
Oh, I know, but I'm looking at this picture. Aside from the fact that I said it already, it does detect forward and back. That's correct. But when you look at the picture, can you see why it detects forward and back? That's what I'm asking.
Is it tension on the cilia?
Yeah, so what? So, yeah, the cilia is going to move, right? Since it's on the bottom of the pool, that what happens is as you move, the weight of the otoconia actually allows the gelatin to move, and it causes deflection of the hair cell, which causes depolarization of the nerve, okay? Since it's on the bottom, going forward and back, that is going to move. The jello is going to move. Sabrina, I lost you. I'm sorry. Can you see that? So if you can imagine something that's, even a bunch of pens sitting up like this, as I go forward and back, if there's something with weight and jello, it kind of goes back and forth, forward and back. If I go up and down, it's not going to change it, right? But I've got to go forward and back to have this go like that.
What is the little dots?
They're called otoconia. They're calcium carbonate crystals. They add weight to the system. Think of them as rocks. Okay, you think about them as heavy rocks. Hannah?
Would it not also detect side-to-side motions?
Yeah. Forward, back, so linear.
Okay, so any linear
So
motions,
forward, back, it does not detect up and down. It detects forward and back and side-to-side motion. Yeah, so anything, and not even side-to-side, I mean, you can go like diagonal motion. Anything in a linear motion, linear forward and back, side-to-side, around. Right? It's going to detect any kind of movement that isn't up and down because of the orientation of the hair cells and the gelatinous matrix with the rocks on top. When those rocks are going to be affected by, inertia, right? So you're just going to move. Yes, Sabrina.
So there's an issue with that. Is that what you're fixing when you do the head tilt thing with patients?
Okay, good question. So the head tilt thing with patients is to correct a problem called BPPV, benign paroxysmal positional vertigo, and we'll get there as we go. But what happens in those patients is these otoconia rocks, they become non-embedded, and when they fall off and get stuck in the endolymph, they end up in the semicircular canal, which is, you have to figure out which semicircular canal is affected by doing the head thing, and then you can actually position the head in certain ways to make the otoconia come out of the semicircular canal and go back in the utricle. Does that make sense? Thinking about it that way? Yeah, the calcium carbonate crystals, one thing that can cause it is BP, dehydration, because these calcium carbonate crystals are constantly being released into the endolymph, and then they dissolve, right? And then they reform, and they attach again. Okay, but if you're dehydrated, they can't dissolve. And then there's a problem with getting them stuck in a canal. But we'll get there. That's coming. Any other questions? Okay, so the utricle is responsible for detecting forward and back, side to side motion, right? Now, the saccule then has to be involved in detecting up and down motion. Okay. Oh, let me label this before I don't do this. This whole thing is a sensory organ. Okay, because of the setup, it is considered the sensory organ. Sensory organ's exactly the same in the saccule, in the utricle and the saccule. Okay, this whole sensory organ is called a macula. I really think the hardest part about vestibular stuff is the vocabulary. A lot of new words and a lot of really weird words, right? But this whole thing. This is the hair cell, the gelatinous matrix, and the otoconia is a kind of sensory organ called the macula. Macula. Kind of like Dracula with an M. Macula. Okay, and that's the name, so this whole thing is the sensory organ. Now, the sensory organ is going to be the exact same over here in the saccule, except there's one big difference. Can anyone tell me what that big difference has to be? If it's, huh? Where is it located?
On the side wall.
So it would be on the side.
It's on the wall of the pool. Right, exactly. That's it. That's exactly right. So it can't be on the bottom. In order for it to detect up and down motion, it has to be here on the wall, because that way the cilia are going to bend this way if I'm sitting on the wall. So let's see if I can draw that here on the wall. So in the saccule, I've got okay. Same situation. All I'm doing is I'm drawing in my hair cells. Exact same picture. Only now we're positioned on the wall of the pool, so I can detect up and down motion. And coming out the bottom of the hair cells are going to be, again, vestibular portion of the 8th cranial nerve. It's axons. And it's going to join. This is all coming from one side, so it's all going to be part of this information coming out. Yes?
So the box is, like the green, for instance, is that just like sat down in the pool, or is the green embedded into like underground, like under the pool, and the cilia sticking up through the bottom?
So the membrane itself is part of this. So imagine this wall of the pool is the membrane. So like a liner, the liner of the pool is there. Coming like off of the liner of the pool, you have those cells coming out. That works. Any other questions? Okay, so, and this is on it, now it's on its side. So if this is the wall of the pool, the macula is going to be sitting in this direction. Okay, so bless you. Same setup. So we have our cilia sticking out, bless you, sticking out from all the different hair cells, right? And we've got the gelatinous matrix that we said is over top. It all still applies. Okay, and then on top of the gelatinous matrix, we have our otoconia. It just add a little bit of weight to the system. So now, gravity is going to affect the up and down. And this is the one that gets activated. So for example, if you're riding in an elevator and you can feel that you're going up or going down, that's the job of the saccule. Okay, the job of the utricle is going to be more if you're riding in a car and or on a skateboard or walking, so that you're translating in a specific direction. And I can tell you that the vestibular system is very tightly connected to your visual system. We're going to talk about that at the end here. Has anybody ever been in a car at a stoplight and you see the car next to you go forward and then you hit the brakes because you think you're going forward? Because that's how tightly connected the systems are. Vision goes with vestibular. Okay, we're going to talk about how that works. Okay. Questions about where? Yes, Ben.
So it's not the otoconia that detects the motion, it's like the utricle and saccule?
The thing that detects the motion is the sensory organ that's called the macula.
Oh,
Okay? This whole thing itself, with your hair cell, your gelatinous matrix, and your otoconia on top, that whole thing is called a macula. That's the sensory organ that detects motion. In the utricle, the macula happens to be on the floor, so that it only works forward and back, side to side, whatever. But in the saccule, it's on the wall, so it's activated by gravity, right? So as gravity goes up and down, that's going to change, or that's going to cause depolarization of the macula in the saccule. Depolarization of the macula in the utricle is going to happen when there's linear motion. Got it? Other questions? You guys, do you have a question?
No, I'm good.
No? Okay. I don't know how a straw works, but hey, whatever.
No, it's probably like that, because it's like a pool.
Oh, good. Okay, perfect. Okay, that's this, saccule and utricle sensory organs. Let's move on to, and I said, so the sensory organs inside the vestibule are the saccule and the utricle. The semicircular canals also have sensory organs that we need to talk about, okay? And they're a little bit different. All right. So I've labeled this as the right side, so the right side and the left side. And just to make it easier to see, I'm going to start out here and just put a dividing line in the middle. So this is really what I've tried to do here is this is the horizontal canal. This is the horizontal canal from the right side. So this is my horizontal semicircular canal from the right side. And all I've done, so realize that right in this position here would be the vestibule. Okay, just looking at the right side. So all I've done is I've taken the horizontal canal, I've popped it off the vestibule, and where the vestibule will be or should be, I've left a space. Okay, so everybody see that? And this is the right horizontal canal, and then we have a similar situation happening on the left. Okay, this is my left horizontal. Horizontal semicircular canal. Okay, and again, on the left side, this is the horizontal canal, so it'd be on the outside. That means that this is the space where the vestibule would be, on the left side. Is that clear? See what I've tried to do? So I've just separated the right and the left horizontal semicircular canals. Got it? Okay, so nothing too new yet. So inside, I'm going to start drawing inside my bony labyrinth, which I depicted here. I have my membranous labyrinth, right? So I'm just going to draw my membranous labyrinth in here on the right side, and then the membranous labyrinth lines the semicircular canals, but then when you get to this big bony bulge, which is the ampulla, you have a situation where off of the membranous labyrinth, you have some cells. Again, these are tall cells. Okay. These are just coming off the membranous labyrinth. They're just tall cells. And the same situation exists on the left side in the horizontal semicircular canal. We have your membranous labyrinth here. And then on the bottom in this ampulla, you have some tall cells. Okay. So, we just made an extension. And the only thing we've added so far are these cells that are coming off the bony or the membranous labyrinth in each of the semicircular canals. Very good. Question?
Those cells line the entirety of the inside of the ampulla, or are they just like on one side?
They're on one side. They're just, yeah, because they're going to detect their job. We'll talk about that in a minute. You'll see why. Any other questions? Okay, good. Let's take a 10-minute break.